OVA. Mr. R wanted us to learn, and I, Forrest, from his third period chemistry, have learned to A/N, open parenthesis, capital A, capital B, capital C, you choose and smile, close parenthesis, level, the following concepts from the first 12 chapters of our chemistry book, period. This is not an inclusive list, but my selection of concepts from each chapter that I will remember. Chapter 1, Introduction to Chemistry. In Chapter 1, we learned our introduction into chemistry and what our course would entail. Here are a few things we discussed in Chapter 1. Because both living and non-living things are made of matter, chemistry affects all aspects of life and natural events. There are 5 traditional areas of study in chemistry: organic chemistry, inorganic, biochemistry, analytical, physical chemistry. Effective problem solving requires a plan and the implementation of said plan.
Alright, I guess I got a robot for a partner today. So, Chapter 2, Matter and Change. Chapter 2 covered matter and how it changes, an important aspect in chemistry. Properties of matter. Properties used to describe matter can be classified as intensive or extensive or intensive. Based on distribution of their components, mixtures can be classified as heterogeneous mixtures or homogeneous mixtures. During chemical change, the composition of matter always changes. Compounds can be broken down into simpler substances, but chemicals means, however, elements may not.
Chapter 3, Scientific Measurement. Chapter 3 involved scientific measurement and how we use the SI-based unit system to study chemistry and other fields of science. Measurements are fundamental to the experimental sciences. For that very reason, it is important to be able to make and decide if those measurements are correct. In scientific notation, a given number is written as the product of 2 numbers. The International System of Units, SI-based units. The 5 SI-based units commonly used by chemists are the meter, the kilogram, the Kelvin, the second, and the mole. Conversion factors. A conversion factor is a ratio of equivalent measurements. When a measurement is multiplied by a conversion factor, the numerical value is generally changed, but the actual size of the quantity measured remains the same. Density is an intensive property that depends only on the composition of a substance, not the size of the sample.
Chapter 4, Atomic Structure. The structure of the atom was discussed in this chapter. Here are a few pointers explaining Chapter 4 and the atomic structure. Atomic theories. Democritus, 460 BC to 370 BC, believed that atoms were tiny particles that were both invisible and indestructible. John Dalton, 1766 to 1844, used experimental methods to further perfect the ideas of Democritus on the atom. It included the theory that some atoms were identical and that they were also very tiny particles, yet they had subdivisions within them. Despite their small size, the structure of an atom can be viewed with the assistance of a scanning, tunneling microscope.
Chapter 5, Electrons and Atoms. Chapter 5 further explained models of the atom and began touching on the subject of subatomic particles, more specifically, explaining the electron and how it is configured within an atom. Rutherford's atomic model could not explain the chemical properties of elements. Bohr proposed that an electron is found only in specific circular orbits around the nucleus of an atom. The ways in which electrons are arranged in various orbitals of the nuclei of atoms are called electron configurations. 3 rules to electron configurations: the Aufbau principle, the Pauli exclusion principle, Hund's rule. Physics and the quantum mechanical model. The amplitude of a wave is the wave's height from 0 to the crest. The wavelength, represented by Greek letter lambda, is the distance between the crests. The frequency, represented by Greek letter nu, is the number of wave cycles to pass a given point per unit of time.
Chapter 6, the periodic table. In this chapter we learned about how all the elements are organized by their similarity to each other, kind of like genes in a department store. Chemists used the periodic table to organize and easily identify items, or elements. The first organized periodic table was developed in 1839 by chemist and physicist Dmitry Mendeleev. The periodic table displays the symbol and names of the elements along with the information about the structures of their atoms. In general, atomic size increases from top to bottom within a group and decreases from left to right within a cross period.
Chapter 7, Ionic and Metallic Bonding. This chapter covered different bonds between atoms, specifically ionic bonds and metallic bonds. Valence electrons are the electrons that remain in the highest occupied energy levels of an element's atom. To find the number of valence electrons in an atom, simply look at its group number. The octet rule. Atoms of metals tend to lose their valence electrons, leaving a complete octet in the next lowest energy level. Atoms of some nonmetals tend to gain electrons or to share electrons with another nonmetal to achieve a complete octet. Ionic compounds, 3 properties. Although they are composed of ions that are electrically neutral, they conduct electrical current when dissolved in water or melted. Most ionic compounds are crystalline solids at room temperature.
Chapter 8, Covalent Bonding. Chapter 8 explained what kind of information a molecule formula translates and provides, the difference between ionic, metallic, and covalent bonds between atoms, and how electron dot structures represent shared electrons. The atoms held together by sharing electrons are joined by covalent bonds. Molecular compounds tend to have relatively lower melting and boiling points than ionic compounds. The molecular formula shows how many atoms of each element a molecule contains. A covalent bond electron sharing usually occurs so that the atom contains the electron configuration of noble gases. Just as an atomic orbital belongs to a particular atom, a molecular orbital belongs to a molecule as a whole.
Chapter 9. Chemical names and formulas. In this chapter, you learn to distinguish between a cation and an anion, how to classify representative elements, define polyatomic ions and monatomic ions, and the basis of writing formulas / names for ionic compounds is discussed. Naming ions. Monatomic ion. An ion that consists of a single atom with a positive or negative charge resulting from the loss or gain of one or more valence electrons. Polyatomic ion. A tightly bound group of atoms that behaves as a unit and has a positive or negative charge. Cation. A positively charged ion. Anion. A negatively charged ion. When the metals in groups 1A, 2A, and 3A lose electrons, they form cations with positive charges equal to their group number. Charge of any ion of a group A nonmetal is determined by subtracting A from the group number. To name in a binary ionic compound, place the cation name first, followed by the anion name. Naming acids. When the name of the anion X ends in I, the acid's name begins with the prefix hydro. The stem of the anion has the suffix ic and is followed by the word acid. When the anion name ends in ite, the acid name is the stem of the anion with the suffix us followed by the word acid. When the anion name ends in ate, the acid name is the stem of the anion with the suffix ic followed by the word acid. Use these rules for writing the names of acids in reverse to write the formulas for acids.
Chapter 10, Chemical Quantities. This chapter discusses the 3 most common means of measurement: the mole, mole to mass, and mole to volume relationships, and percent compositions and chemical formulas. You have to measure the amount of something in 3 different methods: by count, by mass, and by volume. Roses come in the dozen, just like the mole. A mole substrate involves the use of Avogadro's number. It is 6.02 times 10 to the 23rd particles of that substance and is the SI unit for measuring the amount of substance. A mole of any substance contains Avogadro's number of representative particles, or 6.02 times 10 to the 23rd representative particles.
Chapter 11. Chemical reactions. Describing chemical reactions, learning how to identify them and write them, and how to work with chemical reactions in aqueous solutions are all discussed in this chapter. To write a word equation, write the names of the reactants to the left of the arrow separated by a plus sign. Then, write the names of the products to the right of the arrow, also separated by a plus sign. Write the formulas of the reactants to the left of the yield sign, arrow, and the formulas of the products on the right, arrow. The 5 general types of chemical reactions are as follows. Combination reaction, where two reactants react to form a single product. Combustion, where heat is mostly involved and combustion occurs during the reaction. Decomposition reaction, where a single reactant reacts to form 2 different products. Single displacement, double displacement.
Chapter 12, Stoichiometry. Chapter consists of the arithmetic of equation chemical calculations and Repeated percent yield. The arithmetic of equations are used in daily life. A balanced equation provides the same kind of quantitative information that a recipe does.
Woohoo! I know that's the most thorough. He went to the woodshed on that one, didn't he?
You just wrote a whole